Good afternoon, everyone. Welcome back to Tech Talk Tuesday. Sorry, we're a little bit late starting, having a few little IT challenges, but hopefully we've got them sorted. So, welcome aboard. If you're joining us for the first time, welcome to Treadwell's Tech Talk Tuesdays. We hold these sessions every second Tuesday at 1:30 p.m. Here in New South, or 1:30 p.m. on New South Wales time, where I am this week. We'll hold them every second Tuesday. We try and keep it to 15 minutes or less, and we have a look at something relating to FRP or relevant design standards or something like that. If it's not the first time you join us, welcome back and thanks for joining again. Edward Titley is my name, and I'll be running through today for you just a bit of a comparison between the loading requirements specifically of AS 1657 and AS 1170.1, handrails versus barriers. This is, as with all these sessions, obviously a couple of things to keep in mind. One, we are providing a review or a commentary on the standard, so what we say shouldn't be regarded as site-specific advice or anything like that. If you need to discuss anything project or site-specific, please reach out. Secondly, we're obviously not Standards Australia, so I can't tell you what Standards Australia meant when they wrote the standard. All I can simply do is show you what it says. And thirdly, leading on from that, obviously standards are subject to interpretation. I may interpret differently to someone else, so with that in mind, this is purely a commentary or a review rather than specific project advice. So with that out of the way, we're looking at this topic because it's a question we get reasonably frequently, as far as what product or what handrail system is suitable for use in a particular type application. So hopefully we'll clear up a few things here, as far as what is and isn't, shall we say, cross-compatible between the standards, and then a bit of an idea of where it's appropriate to use one standard or the other. We'll have a live Q&A session at the end, but I've got the Q&A window open now, so please feel free to ask any questions as you go along. If we can if we can incorporate the question into our presentation, then we'll do that. And lastly, please, any feedback on the sessions, good, bad, or ugly, if it was a waste of time, please say so. If it was worthwhile, please say so. And if you would like a particular topic to be featured in another webinar, please say so. And lastly, this is our second to last webinar for 2023. So the next one will be in 2 weeks. The last one will be in 2 weeks' time. And the topic for the last webinar for the year is floor loadings, 1170 versus 1657. So hopefully you find that worthwhile. But as I said, sorry to run late. Hopefully we can get this over and done with quickly and not run too much behind time. So a couple of things, and look, we've looked really at 1657 handrail design in another webinar, so I won't go too far into that. We haven't done 1170 design yet, but we certainly could do that. If you'd like to see that, put it in the chat. But a bit of basic discussion. Firstly, handrails, guardrails. Handrails should have no sharp edges or splinters, which would cause injury to users. That seems fairly obvious. Handrails shall not rotate within their fittings, so the tube itself cannot be able to be rotated. That would require fixing or welding to prevent that. And lastly, handrail and infill should have a wind loading considered to AS 1170.2, obviously as appropriate for that application. So, loading requirements of AS 1657 firstly. So, and all these, I've excluded the bit about the direction. I think it's probably fairly straightforward as to which direction the loading is going to be in. It's typically upwards, inwards, or outwards. So the top rail, mid rail, or the post must be able to withstand a concentrated loading of 600 newtons. There's deflection limits as part of the testing, as part of the standard. 1657 gives a detailed testing procedure, and it also gives a table of the items that have been calculated to be able to withstand these imposed actions, and therefore they can be used and considered acceptable with certain sizes of steel and a couple of aluminium grade profiles as well. Also on the top or mid rail, 350 newtons per meter as a line load, if you like. and then 100 newtons on the toe board. As I said, these have all got deflection limits. And then on the infill, if it's applicable, 500 newtons as a concentrated load and a UDL of 1 kPa. Now, that all seems fairly straightforward. However, if we go to 1170, which we'll do shortly, we often get asked this. I'll go back to the photo. The product in this photo is our Rail-X product. It's an equivalent, if you like, to your normal sort of ball and tube handrail, industrial applications, back of house access, that type of thing. AS 1170 talks about barriers. Barriers including parapets, balustrades, and railings, together with members and connections that provide structural support, shall be designed to sustain imposed actions given in Table 3.3. We'll look at 3.3 shortly. Top edge of the handrail should also be designed for the case where a concentrated load of 0.6 kilonewtons positioned for the worst possible effect acts inward, outward, or downward. So this is Table 3.3. Hopefully you can read that. Now, if we look at these loadings as compared to AS 1657, we can see that there's only really two aspects where an AS 1657 compliant handrail is able to be used outside of that industrial access. And as I said before, this is general advice, not site-specific advice. And that would be something like this Class B here, light access stairs and gangways not more than 600 mil wide, and also the second category, fixed platforms, walkways, stairways, and ladders, which is AS 1657. Also, potentially able to be used in a Class A area, areas within or servicing one dwelling. So if we look at all these other items, other residential, and then we go to Class C 1, 2, 3, and 5, all these loading requirements are greater than AS 1657. So therefore, a handrail compliant to AS 1657 has very limited usage outside an industrial type application. So considering, we'll have a look at Class C, and we'll do that because these are the most common balustrades or handrails we do in FRP is either AS 1657 or a C3 or C5 loading. So from left to right, horizontal, vertical, and inwards, outwards, downwards, kilonewtons per meter on the top edge of the handrail, and then next the infill. So top edge horizontally, 0.75 kilonewtons for a C3 handrail, kilonewtons per meter, I should say. Also the same vertical, and inwards, outwards, or downwards, 0.6 kilonewtons as a concentrated load. And we need to consider a loading of 1 kPa horizontally on the infill and 0.5 kilonewtons in any direction on the infill. C5, we see these increase both on the infill to 1.5 kPa and kilonewtons, and also as a kilonewtons per meter loading on the horizontally, 3 kilonewtons per meter. So where would I use one or the other? The most common handrail we do in our public infrastructure projects is a C3 handrail, stairs, landings, external balconies, edges of roofs, etc. Typically, we wouldn't see a C5 loading required often. However, some applications where there's heavy usage, things like very popular public jetties or viewing platforms or those sort of things, you may need to go to a C5 loading. As this standard says, theatres, cinemas, grandstands, etc. So just trying to clarify this topic, this coverage content's probably a bit dry, but trying to make sure we're all clear as far as what is interchangeable. And the short answer is that a handrail compliant to AS 1657 is really unable to be used for in most other applications other than a Class A handrail servicing one dwelling, or light access stairs or gangways not more than 600 mm wide, or fixed platform stair or walkway, stairways and ladders, which is effectively AS 1657. So a couple of applications just to have a look at and think about. This is our Rail-X FRP handrail system, which is tested and compliant to AS 1657 2018. These are installed in a rail maintenance site, so the access for this structure would be maintenance personnel. It's back of house, if you will, and hence an AS 1657 handrail is the most appropriate there. This is our NatureTread FRP balustrade system. This is typically a C3 compliant structure. So you can see this here is also compliant to AS 1428, which is a different probably topic for another webinar. But you can see this has an infill and a grab rail also to be accessible for disabled persons. Now the other things, the other standards we sometimes see handrail required to be designed to. We've discussed AS 1170, as we mentioned, C3 or C5 handrails are typically the most common we'd offer. AS 2156 is the walking track standard. Some of the requirements are similar to 1170. Some are similar to AS 1428, which is disability access. Now, happy to have that discussion on a project-specific basis. And if you're interested, please put in the comments 2156 versus 1428 versus 1170 could be another topic for a webinar of the future. And then the last requirement, or the last thing we get come up is AS 5100, which is the bridge design code. Not common, however, some authorities require even pedestrian access bridges to be compliant or load rated according to AS 5100. A lot higher loading. I'll just go back a couple if I can. This picture here, this is an AS 5100 compliant FRP balustrade system. As you can see, it's quite heavy duty. It's quite a large structural section, and that's required because this jetty has a horse-drawn tram. This is Victor Harbor in SA. Has a horse-drawn tram that runs along it, and also may have maintenance vehicles on it. So hence the decision was made to go to 5100 for that barrier. That's about it. As I said, sorry, it's probably reasonably dry content, and I hope I haven't bored you all to death. But as we can see, there's little crossover really, especially from AS 1657 to anything that would be used in the public area, which would be a C3 or C5 handrail to AS 1170.1. It's not acceptable, or it's not workable to apply a handrail solution, if you like, that's used in 1657. That's not able to be used in a public area where a 1170 C3 or C5 handrail compliance is required. And the last thing is we often see wind load overlooked. Not that it's usually significant, especially on a fairly small round tube, 50 mil round tube, but is something that needs to be considered as well. Hope I haven't bored everyone to death. Please, if I have, say so. If I haven't, say so. Always glad of feedback, good, bad, or ugly. We want these webinars to be informative. That's the end of our content for today. As I said, we've got one last webinar this year in 2 weeks' time, and then I'll be looking at floor loading requirements, 1657 versus 1170. And if you'd like to reach out and discuss the project, you can get us on 1-800-246-800 for Australia, 0800 244 600 for New Zealand, or sales@treadwellgroup.com.au or hello@treadwellgroup.com.au. Thanks for joining us, and we'll stay online, answer any questions you might have. Got a couple of questions come through. Firstly, thanks, Les. Glad it helped clarify a few things. Question from Betty in regards to, can a handrail be used for any other purpose other than a barrier, for example, connecting with a hoist? Look, that's not really something I can answer here and now. The handrail systems are obviously designed for the loadings we've looked at, being 1657 or 1170. If you are looking to to connect the hoist to a handrail. Some other things we see requested are light poles. It's a common one that would need to be looked at on a case-by-case basis. Something like a light pole is obviously quite likely subject to a wind load as well. We would need to review that on its merits or on its on the numbers that are required from that. So sorry to give a roundabout answer, but potentially yes, but also quite likely one of the standard products that just specifically meets the C3, C5 loading or 1657 loading would need to be modified to make it suitable to take those other loadings. If you've got something specifically you're thinking of, just flick it through to hello@treadwellgroup.com.au, pictures or drawings or technical details, and we'd be very happy to have a look at it for you. So it's 1:49 here where I'm here in New South Wales. I'll just stay on to 1:50 if there's any other questions. Otherwise, we'll wrap it up. And if you think of something in the meantime, hello@treadwellgroup.com.au or 1-800-246-800 for Australia and 0800-244-600 for New Zealand. Does guardrailing as opposed to handrailing need to be continuous? Thanks, Mara. Good question. Does it need to be continuous or can it be in panels? Are you thinking A1657? I'm guessing here. Look, allowance is made for both. And there's requirements given around the gap between your adjacent modules to allow sufficient hand clearance, obviously not be too large. My personal preference, and this is a preference for what it's worth, is I would suggest you would make handrail continuous where you possibly could. I think it feels more secure to use. So I said that's my thought. Both are acceptable according to the standard, but we would typically suggest going to a continuous guardrailing type system, top rail, mid rail stanchions, infill if necessary, rather than having modules. However, from a manufacturing perspective, having 50 individual modules of the same thing may be more practical, and it is permissible by the standard. But yeah, I would personally steer you towards a continuous handrail where possible. If you'd like to discuss that more, just drop us an email, hello@treadwellgroup.com.au, and I will bring up the relevant aspects of AS1657 and can discuss that in more detail with you. Hope that makes some sort of sense. Looks like that's about it. Thanks again for joining us. See you in 2 weeks for the last webinar of the year, where we'll look at floor loadings between AS1657 and AS1170. G'day, Les, another one. The continuous handrails need expansion joints past a certain length. Look, this would depend obviously on the material. If you're thinking FRP, then typically not. The coefficient of expansion of FRP is very low, virtually negligible. So not typically. If it was steel or aluminium, then that may need to be considered, or would need to be considered, I guess. But whether you typically come across a continuous length of handrail on a site that that would be long enough to warrant that would be a different discussion. But on FRP, I wouldn't typically see it being needed unless it was in the order of hundreds of meters of continuous straight length handrail, and even then, the coefficient of expansion of FRP is very low. But next to a conveyor belt, how sort of long are you thinking? If it was FRP, my short answer would be no. If you want to drop us an email, I can give you get you back the coefficient of expansion of FRP. But off the cuff, something like a tenth of steel from memory. It's significantly lower. So wouldn't often see expansion joints needed with an FRP structure at all, and especially something like handrail. I don't know. Does that make some sort of sense? No worries. As I said, look, drop us an email if you like. I think you should have my email address, and happy to send you back that data to have a look at and have a discussion around. Cool. Looks like that's it. Thanks all again. See you again in a couple of weeks. And always appreciate your feedback. Always feel free to email through any webinar suggestions or topics you'd like us to cover. Always happy to, always looking for new content that you're going to find useful or of some sort of value. So thanks again. Appreciate you joining us and enjoy the rest of your day. See you in 2 weeks. Cheers.